This exact type of question shows up on your calculus exams all the time. We're finding where a function is concave up and concave down using the second derivative. Let's break it down step by step. So let's find the intervals on which f of x is concave up and down. We can do this in a few easy steps. Step 1 is to just find the first derivative. So f prime of x is equal to 15 x to the fourth minus 15 x squared. Next, we find the second derivative. You do this by just taking the derivative again. So basically the derivative of the derivative. If we do the power rule again, we get 60x cubed minus 30x. The second derivative gives us information about concavity. But to actually get this information, we need to expose the roots and solve for them. So you can find the roots we're looking for by setting the second derivative equal to 0 and factoring. So 60x cubed minus 30x is equal to 0. I'm going to factor out a 30x. That gives us 30x. And then in brackets, we have 2x squared minus 1. And that's all equal to 0. Let's get the roots now. So we have 30x here is equal to 0, which gives us x is equal to 0. And here we have 2x squared minus 1 is equal to 0. This gives us x is equal to plus or minus 1 over root 2. So all we need for the next part of the problem is the roots and the second derivative. Okay, so now that we have all of our information to solve the problem, f double prime and its roots, we can use a number line to figure out what's going on the left and right side of each root. Also, I've approximated 1 over root 2 as plus or minus 0.7. I find it's just a little bit easier to read on the number line. So first things first, let's place our roots on the number line. We have 0 here, we have negative 0.7 on this side, and then positive 0.7 on this side. So the first test number would be here, then we have another one between the roots, right, on the left and right side of each root. And the last one is on the far right side. So what's on the left side of negative 0.7 on the number line, or in other words, what's more negative than negative 0.7? Well, that's negative 1. And then we apply this same logic to the rest of the problem. So what's between negative 0.7 and 0? Negative 0.5. And then we can fill in the rest. Positive 0.5 and positive 1. So now let's input our test numbers into f double prime. On this interval, we're getting f double prime of negative 1. Then we need f double prime of negative 0.5. Then f double prime of positive 0.5 and positive 1. Computing this, I get a negative for f double prime of negative 1. Then I get a positive for this one, negative for this one, and a positive for this one. So the second derivative tells us information about concavity. When it's negative, in the first case here, it's concave down. When the second derivative is positive, it's concave up. And now we can fill in the rest. But the question asked at what interval? So the interval from left all the way to negative 0.7 is negative infinity to negative 0.7. Then we have an interval between negative 0.7 and 0 here. That's concave up and just negative 0.7 and 0. Now we have our other interior interval, which is 0 and 0.7, and that one's concave down. And for the last one that's concave up, we have 0.7 and positive infinity. For those who've stayed this long, I'm just going to show you the other way to write the intervals, because I know sometimes your teacher might be picky on how you do them. This bracket, negative infinity to negative 0.7, you can write this as x is less than infinity. For the interior ones, you say x is in between those numbers, so negative 0.7, so negative 0.7 and 0. So x is in between negative 0.7 and 0. Same logic applies for this one. And then the other one, you probably did it already. This one is x is greater than infinity. All right, thanks for watching this video. Hope you found it helpful. Have a great rest of your day.